Hey everyone, if you guys remember that challenge problem lecture that we did a couple lectures ago, this is going to be an application of that challenge problem. So let's get started. Alright, we're going to head over to the computer and work through an example together, so I'll see you there. Hey everyone, so just like the last couple lectures, this is how it's going to work. I'm going to set up the problem, and then you're going to pause the video, and then we're going to work through the solution together. So, I'm not going to throw a bunch of words at you. I'm going to set up the problem with you, and then we're going to solve it together. So here's the problem. In this case, I have an IQ of, and I actually wrote this down, 77.6, which is way over here on this bell curve. And remember, this is the IQ bell curve, has an average of 100 and a standard deviation of 16. Now, the area between this IQ score and another IQ score, and I'm not going to tell you what this IQ score is. This area right here is 0.77. The question is, what is that IQ right there? What IQ would give me an area between that IQ and 77.6 of 77%? That's a really tough problem. I want you to give this a shot. There's a lot involved. Pause the video, and then we'll come back and talk about the solution. All right, so yeah, this is a tough problem. It's probably one of the toughest problems I would ever give my students. So let's talk about how we would do this. First off, just like all the other problems, we can't work with an IQ bell curve. We have to work with a z-score bell curve, and a nicely drawn one at that. And we're running into a little bit of an issue here. Trying to delete this. There we go. Okay. Let's try that again. Drawing a z-score. Bell curve. And I need to make it really nice because there's going to be a lot of shading in here. So this has a an average of 0 and a standard deviation of 1. Now, let's try to convert this IQ problem into the standard normal distribution. First off, I have two z-scores, two corresponding z-scores. This one, which is like z1, and this one, which is like my z2. And I know something about these z-scores. I know that the area between them is 0.77. So that area is 0.77. Both of these purple regions they have an area of 0.77. Now, if we knew these two z-scores, we would be able to find, well, particularly if we could find this z-score right here. That's the z-score I really want, because then I can convert that to this corresponding IQ score that we're trying to find. Let me use a different color there. We're trying to find that guy right there. And if we found that z-score, it would kind of help us, because then we can use the formula. Now, we know this IQ, which means we can find that z-score using this formula, z equals x minus mu over the standard deviation. We know x, it's 77.6. We know mu, it's 100. And we know standard deviation, it's 16. So in this case, the corresponding z-score, which, by the way, in this case is z1, left guy, is 77.6 minus 100 divided by 16. And let's figure out what that number is. Negative 1.4. And I'm going to write negative 1.40 because z-scores are always rounded to 2 decimal places and areas are always rounded to 4 decimal places. So in theory, we should add 2 zeros to both of these areas, but it doesn't really matter. So we know what the z-score is. That's good. This z-score is negative 1.40. Now, how do we find this z-score? Well, we don't know the IQ. That's what we're trying to find, so we can't use this formula. Unfortunately, this formula will fail us at this point. And you could try, but unfortunately you won't get anywhere. So we needed some other solution. Now, let's think here for a second. What we could do is find the area to the left of this z-score. So that's this green region right here, which, by the way, is the same as this green region right here. So these two areas are the same. What are those areas? I'm not sure, but we know the z-score, it's negative 1.4, so we can use our z-table to find the area to the left. So I'm going to pull up my z-table right now and find the area to the left of negative 1.40. Let's try to find negative 1.40. Hey, look at that. It's already highlighted for us because I was just doing this problem earlier. It's 0.0808. That is the area to the left of z equals negative 1.40. 0.0808. Let's go back to our bell curves. This area right here is 0.0808. So, how does that help us find the z-score or this IQ score? We still don't know those two things, but now we have some more information about this z-score right here, and let me tell you why. We know that the area to the left of this z-score, I'm going to draw in blue. It's this area right here, which looks to be this purple region plus that green region. The purple region plus the green region, meaning that this is just the purple region plus the green region, which, by the way, is 0.77 plus 0.0808, 0.8508. Well, that's actually really, really important because now we have the area to the left of this z-score. So we can actually find that z-score because we know the area to the left is 0.8508. So let's go back to the table and find which area is 0.80. Hold on. I actually lost it. 8508. We're looking for 8508, and it is right there. So I'm going to use my annotations real quick. So again, the area to the left of this z-score, this z2, is the purple region plus the green region, which is 0.8508. And I'm trying to find what z-score gives me an area to the left of 0.8508. So it looks like that's the area, 0.8508. But I'm going to do some annotations so that you guys can see this a little bit clearer. So let me do this in black. Let's do a different color. Let's do dark blue. So here's 0.8508 right there. Now the corresponding z-score would be, that's the hundredths place, and that is the first couple digits there. So our answer is z equals 1.04. Let's go back to our bell curves again. 1.04, that's not the right. There we go, 1.04. So this z-score right here is 1.04. Now I want to address something that's kind of important. It is possible that you might have thought this would have been positive 1.40. But keep in mind that I never said that this region was symmetric. I did not set that up that way. So don't make that assumption that this number 1.04 or this number, this z-score right here, is just the positive version of that z-score, unless I already tell you that it's symmetric on both sides. So now we have this z-score of 1.04. So let me do Oh, I erased that on accident. Now, are we done here? Still no. The answer is unfortunately still no. We're trying to find that IQ score right there. Now, we found the z-score corresponding to that IQ score, and we are going to utilize that information because we have a formula that we can use. And this formula is z equals x minus mu over the standard deviation. We know the corresponding z-score to this IQ score that we're trying to find. That z-score is 1.04. And we're trying to figure out what x is. That's my x right there. My average is 100, and my standard deviation is 16. So now it's a matter of solving for x. Now, we've done this problem so many times, so I'm going to skip the algebra here. I'm going to assume you know how to do this. 1.04 times 16, and then add 100, and I get an IQ of 116.64. And that is my answer. That is this IQ score right there. So voila, we have found the IQ score that corresponds, basically the answer to this problem. Now, this problem is not very applicable because it's rare that we would ever need to find something like this, but it's important still to know how to manipulate this, how to do this problem, because we're manipulating with the z-table, with the formula, all over the place here. We're trying to get as much information as we can, and this is one of those problems that we're just going to be going back and forth, formula, table, formula, table, table, formula, formula, table. In this case, though, because we know and we've conceptualized what each number represents, hopefully we can use those two things, the table and the formula, to our advantage to try to find these numbers. I hope this helps. Thank you guys so much, and I'll see you in the next video.